Hey guys, we are now recording. We're going to get started. So today we're going to continue what we started on Tuesday, which was essentially looking at PyCryptoDome, the library. Okay. So we're still going to continue looking at the algorithms and how they work throughout the semester. But this library is actually very useful, not so much to understand the algorithms, but just to understand how to encrypt and decrypt things and achieve all the pillars, right? So do we want to achieve confidentiality, integrity? And of course, I introduced on Tuesday authentication, right, with asymmetric encryption and RSA. So digital signatures, certificate authorities, all of that now becomes also something that you can do. So I think we've done AES, encryption and decryption. So you know that that's symmetric encryption. Um, and then on Tuesday, towards the end of the class, the lecture, we started looking at the RSA scripts, right? So we did the first one, which was to generate our public and private key. So we call that script gen RSA. So today we're going to continue with that. Remember, RSA is for sharing the key, in this case, something like the AES key. All right. And then um, these scripts, once I finish, which hopefully I'll finish today, you will have a homework assignment and then you will have a set of problems that you need to demo in class. So you need to I'll need to sit with you guys with the two partners and I'll ask you some questions, send this file, achieve confidentiality, achieve integrity, achieve authentication, and so on. So we really want to get these scripts completed, and they're not, complicated because they're just using a library. Are there any questions before I get into the scripts? All right, remember all of this is in the GitHub. You can get it from there. Just go to the PyCryptoDome folder, and you'll find all of them. There may be multiple versions of them, as I make tweaks over the years. So just make sure you grab usually the latest one is the best one to grab. Today, definitely, we're going to do the RSA ones, and maybe we'll get into digital signatures and things like that. So, yeah, that's the goal. All right, so I'm recording and the VM is on, so let's log in. Well, let's open up the terminal. We're going to navigate to the same folder, the desktop. Remember, with cryptography, you end up having a lot of files, right? So make sure you have good folders, good organization. It's going to help you out a lot. All right. So we need to go to ITS fall 2025. It's just fall 2025. ITS 350. There. And we are using PyCryptoDome My. I'm going to go in there. Okay. Clear. So as you can see, our set of scripts is starting to grow. We have an AES decrypt. We have an AES encrypt. We have several files that hold the key, hold the bin file. So usually when I remember in a few weeks, we're going to have the scavenger hunt. And I think I've explained to you that there's one big secret, right, that you need to decrypt. But to be able to decrypt that secret, you're going to need 3 keys. Do you see what I'm saying? So it might be as simple as key 1 plus key 2 plus key 3, and you just append them or concatenate them. But each one of those keys you'll have to figure out from one of the techniques that we have discussed. So for instance, one of the keys will be hidden and you have to break RSA to get it. Does that make sense? One of the keys you'll have to break using the AES algorithms, possibly these scripts. Okay. Now I usually mention these things and I sometimes provide the scripts, but it's good for you to have them in your GitHub available and so on. All right. So I'm just giving you clues right now. Some of these scripts I will use to encrypt one of the keys. The RSA that we saw a couple of weeks ago that was from scratch, you'll use to break RSA, and one of the keys will be hidden there. And the third one, I haven't really decided yet, but it'll be something like that. Does that make sense? So you have to go on that scavenger hunt, find all 3 keys using these scripts, and then eventually put them together to break the final encryption. In terms of time, I've seen students break this in 15 minutes. So it's really, if you know what you're doing, but if you don't, and you're just trying to learn it it'll take you the whole 2 hours. Okay? So it's not meant to be a long exercise. So anyway, I will certainly use some of these scripts to hide one of the keys. All right, so let's go ahead and take a kind of review really quickly what we did on Tuesday. So we effectively looked at Gen RSA keys. That was the script. Here it is, and you can see it's pretty straightforward because we're using the PyCrypto libraries that we have available now. Notice we're using a large seed, a random number, 2048, so pretty good security, you could argue. And then remember, with PyCryptoDome, we just create a key object that holds the public and the private key. So it does all the math for you behind the scenes, and then we can just export the public key or the private key, okay? And then all I did is we wrote 2 files. All right, so you can see here we have cat of public.pem, that's the extension, consistent with what OpenSSL uses. You can see that there. In a future lecture, I'll give you the code so that we can extract from this format the actual values like the E and the N and so on. But that'll be probably next week. And then let's do private. And you can see it's much longer as you understand that the D parameter and it's a bit longer. All right, so we've done this part, which is good. So what does that mean? It means you've created your keys. So what do you do now? You're working with your partner, in the problems, you're going to send them your public key. I strongly recommend that you rename this something like public Bob, public Alice, so that you can distinguish them, and then that's what you email. You should not send the private key because that's actually your key. Do you guys see that? And then after that, just disable the Gen RSA keys function. I used to have this in the code, and students would always run this function every time they were encrypting or decrypting. And so I eventually just decided it's better just to give them a separate script so that they're not doing that all the time. All right, so now just use it, and then unless you lose it, it gets corrupted, you really shouldn't have to run it again, okay? All right, so now we're ready for the next set of things. So we need to encrypt, and actually the thing that we want to encrypt is already in our folder, right? Which is the AES key. If you remember, when we started playing with the AES encrypt and decrypt functions, we generated a key. And we conveniently saved it to this text file. So that is, although it's hard to read, it is in plain text, technically. So we can do cat AES key.txt. And that is actually our 16-bit symmetric key that we're using for AES. So I recommend that you stay with this approach of saving the plain text in this format, but you should not send it like this, right? Because it hasn't been encrypted yet. So now we have to go ahead and create the code for that. So let's see. Should be the function RSA encrypt, I want to say. That's in there. So we read so I may not actually, I don't see the exact script here. So we'll just create it. I'll update this later. But let's start with that RSA encrypt. Should be pretty straightforward. So the code should be correct. All we need is to read in this text file. So we are, yeah. So let's do nano RSA encrypt. Say encrypt.py. Okay. So we need the libraries. Crypto dot public key and this should be an uppercase K. Import RSA. And then from crypto dot cipher import to, so there's this PK public key CS1. So this is another library that we can use for encryption for RSA. So it's going to be PK CS1 underscore OAEP. And this is just an implementation, a specific implementation of the algorithm. So let's double check that this will run. Okay, good. So this will run. And like I said, so when you see these things like PK, public key, CS1, OAEP, the OAEP it might be some kind of a more efficient way of implementing the algorithm. It's still based on the same math, but the implementation is a little bit more efficient or, a little bit better. So this is, let's try this one out. Let's do just a simple hard-coded message first, and then we need to add the functionality for the files. So let's do 1, 2, 3, 4, 5, 6, 7. And the size of this may be important, but let's just do this for now. 9, 8, 7, 6, 5, 4, 3, 2, 1. So with that, we're going to put a B in front of this, right? To just typecast this to binary. Okay. And now we need to encrypt the key, because remember, that's what RSA. We're always essentially going to use RSA for the key exchange. and nothing else. Okay, so let's do file out, open. And this is going to be, so this, you should give it a good name. So let's call it encrypted AES key. You know, when you're doing this, you want to label all these files correctly so that it's easy to know what you're looking at. So encrypted AES key. Okay, .bin. This is the symmetric key that you will need to read from the other file and send it to your partner. We're going to be writing, so we're going to say here WB, just like that. Okay. And now what do we need? We're going to be encrypting and sending this message to achieve confidentiality. Therefore, we need a public key. Whose public key? The public key of the recipient, correct? Because only they have the private key that can decrypt the message. So in this case, and that's what I was saying, it's good to label these things. So here, mine is called public key, so that's the name I'm going to use, but I do recommend that you label yours appropriately. So they should be public.pem. And then we're going to say key in equal f.read. Okay, just like that. And then we're going to store the public key. So we're going to say RSA dot import key. So notice here, instead of generating the key as we did before, we are taking the key from our files that we generated maybe yesterday or another day. So RSA import key in. Okay, just like that. So let's try this out. Control X, Y. Clear. Okay, no errors, so good. So we're able effectively to read that file, load it into memory as an object. Now we're going to switch to that PKCS1 algorithm, but it's still the same RSA. So let's go ahead and create a new object here. I'm going to call it Cipher RSA. Cipher RSA. PK CS1 OAEP dot new and we are going to provide the public key that we already read in. Public key. Okay. And so now we can use Cipher RSA to just do the decryption. So we're going to create some variable called encoded data. We invoke Cipher RSA dot encrypt. And what do we encrypt? We encrypt our original data over here. Okay, which would be the key. So just for this example. Okay, and let's just print it for now. So we're going to do print encoded data. Data. So I'm going to hit Control X, Y, Enter. Try it again. And there it is. So we are able to encrypt the message, right? So that's two things we need to do. This is the encrypted symmetric key. So we need to save this to a file. Okay. And then from there, we also need to be able to read from a text file. So we'll add that functionality. Let's go ahead and try this out. So we can print it if you'd like. It's just encrypted. Now we're going to use this one, right? File output, because this is the encrypted AES key, right? What you would send to your partner. This is how you share the secret key effectively. What an elegant solution, right? You just create a public and a private key. They email you that public key, and that's it. And you achieve perfect security. Are there any questions? All right, so let's go ahead and write it out to the file. I'm going to say file out dot write. Okay. And what do we write? We write encoded data. Okay. Encoded data. Yep. And then just, we always want to close our file. So we say file out dot close. Okay. So now we proceed. Clear. All right. No errors. That's a good sign. Now we do ls-l. And we should check that we have this file. Encrypted AES key bin. It's got 256 in there. So we want to take a look at it. And there you go. Do you guys see that? So now you have the perfect mechanism to be able to encrypt your file. Now, the next step that we want to do is, of course, we're almost done here. That's it. That's the beauty of these little scripts. Having them independent makes it, more files, but just easier to understand. So now we go back to the code. Obviously, we hard-coded this, but this is probably not a good approach. Instead, we know that the AES key in plain text format is in here. So we want to read this file in, and this is the thing that the contents of that file will be encrypted. So let's go ahead and do that. Okay, so this data is going to be replaced. You can add a line if you'd like for separation. And now we can say something like F AES plain key, some name. Okay. And we're going to read in that file. So I'm going to say open. And in double quotes, I'm going to specify. So I definitely need to get the name of that file correct. So that was AES_key txt. AES_key .txt. So that's the file. We're going to read it. So that's going to be RB, should be in binary. So that's how we wrote it. That's basically it. Now, data will get the contents of that. So we're going to say F underscore AES plain underscore key dot read. Okay, and then we close F AES plain key by just saying just like and that's it. Hopefully this will work, right? So we're reading in the symmetric key for AES in plain text format. We store it in data because that's the thing that we are going to encrypt, and then we just close. All right, so let's try this out. Whoops. There we go, no error, so that's good. The file should have been generated. So we can even delete it and try it again. So it's, I think, encrypted AES key bin. Let's do RM, encrypted AES key. Okay, it's gone. Do ls-l. We don't see it anymore, right? And so now I'm going to run it again. Okay, good. And there it is again. Make sense, guys? And that's the full pipeline, right? That's it. So now, think about it. Just that little script, just gen RSA and this, and you achieve, that's all you need to establish communication with any person anywhere in the world securely, right? And you can do that just via email, no problem whatsoever. All right, so now we have the mechanism for generating the keys. We have the mechanism for taking the symmetric key, the AES symmetric key, and encrypting it, saving it into this file. So this you send to your partner, whose public key you're using here. Now they, on their end, are going to take that file and they're going to use their private key, right, to decrypt it. And we should get back whatever the value was. Got it? So let's go ahead and do that. And then we need to do the whole pipeline to make sure it works, right? So that's going to be our next approach. Okay. Any questions? Okay. So now we need to write the second script. That's going to be called RSA decrypt. I'm going to do RSA decrypt .py. Okay. We're going to look for this one in the repo. So that should be RSA decrypt. And this one seems to be the right one, actually. Okay, so let's go ahead. From crypto dot public key uppercase K import RSA. From crypto dot cipher import PKCS1 O, should be an O. OAEP. Okay, and I think I have in my notes the specific detail of that OAEP. I can't remember the acronym for it right now. So PKCS OAEP. All right, so that's good. Now we're going to read in we need to read in two files, right? What are they? One is the encrypted symmetric key, and the other one is for the private key, right? So that's essentially, we just need that. So I'm going to create something called file in, open. I need to remember the name of that file again. So this one is going to be encrypted AES key.bin. Encrypted AES key dot bin, just like that. And we're reading, so we're going to say comma RB, which means read bytes. Okay, so yeah, let's try that. Make sure it runs. This is RSA decrypt. Okay, good. That worked. Yeah. So now that just loads the file. We need to read it in. So let's call this encoded data. And we're going to say file underscore in dot read. It's like that. So encoded data file in dot read. All right, now we need to read the private key. So it's a similar process. F equal open private dot pem. This is going to be private dot pem. Say, private dot pem. And then let's say key in, say private here if you'd like. Private key. Key. Let's just say from file. Just, yeah, something like from file maybe to distinguish it from the actual private key. All right, so let's read in. So F dot read. Okay. Then I have the actual private key. Okay, so we're going to do the same. Now we need to add this to the data structure, like the class. So I'm going to do RSA dot import key. This is just loading it into that object. So import key. And here, just use that same variable, private key from file. Private key from file, just like that. Okay. So at this point, we should have our private key loaded. Let's try it. Make sure it works. Okay, no errors. Good. So we're able to load the file. We have the data in there. All we have to do now is decrypt the message. And let's add that. Let's 3 lines of code essentially. So this is going to be cipher RSA PKCS1 PKCS1 underscore OAEP dot new, and we need to provide that. Okay, so now the object has the private key, the algorithm, if you will. And so now we can proceed to decrypt. So I'm going to do plain data. And this is going to be cipher underscore RSA say dot decrypt. What do we decrypt? We decrypt this one, the encoded data. Okay. Just like that, encoded data, and then we can print it out. However, you don't want to print this one out and leave it there because we're using a text file in AES, correct? So we need to do that last part, and it'll just make your life easier. So I don't recommend copy pasting binary and things like that. It's just a bad idea. So instead, but for now, let's just print it, and then we need to add that piece of code. So print plain underscore data, just like that. Okay, so let's go ahead. Okay, and there's your decrypted message. It's hard to tell if it worked or not because obviously the original was binary, right, from the file. However, we did hard code one, so we can go revert back to that hard coded one, which was 1, 2, 3, 4 in reverse. So let's try that. Let's switch to that one and see if we are able to get those numbers. And then if we do that, then we're gonna generate the text file. So that should be straightforward. We just need to go back to the original encrypt message for RSA. This one. Okay, here we are. Okay, so let's enable this data. And we can disable this one for now. So now we're going to encrypt 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8, 7, 6, 5, 4, 3, 2, 1. And let's see if we get this on the other end. Questions? Okay, so Control X, Y, enter. Let's encrypt it. Right, so it's encrypted technically. So now let's go to decrypt. There we are. So it did work. We're able to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so this is great news. We know that it works, right? We have now our RSA encrypt and decrypt. With these two scripts in the Gen RSA, you can now establish secure communications with anyone. And then once you've exchanged this key, then you use AES to actually send a secret message. Okay? So the last part is less about cryptography and more about just being practical. We're just going to now this value here, we want to write it out to a file. Which file? This file, AES key. You see that? Because this is the file that we would use with the AES algorithms. But you have to think that when we did this originally, we were Bob. Now you have to think of yourself as being Alice. So maybe we're going to use a different name. We're going to say AES key decrypted or something like that so that we can distinguish it from the original one, especially in my folder. All right, so I need to do that. So let's go back to decrypt. Okay, so here we can print it out, but really we're going to want to write this out. So we have to create yet another file. Out plain AES equal open and let's call this one AES key decrypted. Okay, .txt. So this is not a bin file, or it could be a bin file, but not an encrypted file. All right, we are going to say here, comma, WB, because we was writing bytes, F out underscore plain AES dot write. And what do we write? We write plain data. And then we just close it. So F out plain data. Just like that. So that should be enough. So let's do Control X, Y, enter. Okay, so if we look, now we have two AES keys, AES key, the original one, and AES key decrypted. So if you're Alice now, when you use your AES algorithms, you're going to use this file. Okay. All right, so now we need to test this whole thing, and this is actually something that you do need to do in your homework, right? And in the demo. So I need to create some kind of secret message, encrypted with AES, save the key, encrypt the key, send the key, and then decrypt the message. It should all check out. So let's go through that whole pipeline. Let's take a look at AES encrypt just so I can remember what it was. And actually, I think we need to do a change in RSA encrypt. Whoops. Okay, so let's enable back using the key. So this is the correct way of doing it, okay? So we want to have, I was just using that for testing and debugging purposes, but now you want to use the right key. Okay, so Control X, Y, enter. So if we do RSA encrypt, no errors that I can see. And then we want to do decrypt. Okay, no errors. And if we do ls-l, notice that both keys have the same size. You see that they're both 16 bytes, right? All right, so that's good. Now we need to do the whole process. The whole process would start with AES encrypt. So let's go there. So now you can achieve both confidentiality, right, and key exchange all in one shot. So let's do, as long as you're using RSA. So let's start with AES encrypt. Okay. All right, so here in AES encrypt, we need to add another piece of code that reads in the text from a file. So on the demo, remember the whole demo will be open the plain text message. I'll ask you to do this and I'll just say something like, today is Thursday, October 30th. Right? So I'm going to change the message. Whatever message you use for your homework, I'm going to change it. So make sure that when you're practicing that you change that message, because sometimes students, they get one to work, but mysteriously, they don't quite know how. And then when I change that sentence, everything breaks. Okay, so just make sure to practice. But that's the scenario. So I'm running through it right now. So instead of data like this, we need to read in from a plain text file. This is the start of everything, the original message, and you will be generating this symmetric key. If you wanted to, you could also run this separately and read another file, but I think that's just adding too much complication. So let's do one here. Let's call it F plain in. It's going to be open. I'm going to say here, this is the original plain text message. So plain message dot txt. Okay, you're going to read it into data. So you're going to do F plain in dot read. And then you just close it, F plain in dot close. Do you guys see that? So essentially, this is the idea. Now I need to create this plain message txt file, which is going to have my secret message. Plain message txt. So notice how many scripts we have in here already, right? So it's quite a few. And we still have a lot left because we have the digital signatures and integrity. Okay. Yeah. So let's do nano plain message dot txt. This is your secret. Okay. So I'm not going to use this phrase this year, but last year in the scavenger hunt, I used a spell from Harry Potter. I can't remember which one. Something like hocus pocus, something like that. Right. So that's the kind of thing that you can, it's something from a movie or something like that, a short phrase. So I don't know what you want me to write on here. Today is um, Thursday, October 30th. 2020. All right, so this would be the secret. Whatever the secret is, formula, whatever your secret plans, whatever it is, this your Swiss bank account, right? So this is the secret that you're sending across the world. You're Bob, you're sending it to Alice. So you need to do the whole process and achieve currently just confidentiality and secure key exchange. There's still integrity, authentication, digital signatures, quite a bit. All right, so we are essentially ready, I think. So, and everything should be done. So my message is there. Now I use AES encrypt. So nano AES encrypt. Okay. Encrypt is going to read the message, is going to generate a 16-bit key, right? It's going to perform the encryption, and it's going to generate AES encrypted bin. That's the file that you have to send, and the key is here in plain text. Okay, so let's go ahead and run it. So now I have to run this AES. Oh, like it. I'm guessing the binary is the problem. If I didn't do, or actually, give me a second here. Let's try RB. Do I? Yeah, this is the part that was, it's either RB or I have to change that. It's the plain text message, which is a text file. Let's see if this works. Okay, so this is a different error. It says the data must be padded to 16-byte boundary for CBC. Okay, so easiest solution for this is to just make it multiples of 16 bits. I mean, plain message, right? So I need to go into plain message. Now you can write code to fix this, or it's fine if you just do 16 bits here, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm short 2. Remove the. Do that. Add it to 16. All right, let's print the line. If you're having this issue, let's just print the line. Wait. Hmm. 44. Oh, did you figure it out?
I removed one more character than you did, and it works for me.
Okay. So this is 34, 16, 32. Oh, okay, let me see. Which, sorry, I need to go to the message. Do you have it like this?
Yeah, I just took out the space between is and Thursday.
Okay. It's Do you have a space up here?
No, I didn't.
Yeah, you do not. Okay. Let's try it again. All right, there we go. It works. So that's where that other one was coming, was this enter, the new line character probably. So make sure the 16-bit write code, better code than me to handle that automatically. How about that? All right. But yeah, so I want to stress that these are common things to 16. If you understand this, is perfectly fine by me if you just correct it in the plain text form. Okay. So yeah, so we're getting there. So we've encrypted something, it would seem. Right, so let's try this again. So Python AES encrypt. In theory, we took the plain text message just now, right? We generated a 16-bit secret key and we encrypted that plain text message. So we have that. So you can actually send that out already, but the problem is you cannot send the key, the secret key just yet because it's still in plain text, this one, right? So what we have to do is now we have to run the RSA algorithm to encrypt this one, okay? So that code should be fine, I think. So let's do RSA encrypt. Let's take a look at it. RSA underscore encrypt. Okay. So this is going to read AES key, which is exactly what we want, is going to, do the file handler. We read in the public key. Remember, this is going to be the recipient's public key. Then we assign it to PKCS1 OAEP, and we encrypt data, which is the secret key, and we save it into a file called encrypted AES key.bin. Okay, so now let's do that one. So RSA encrypt Python. Okay, no errors. That's good. So that would mean that now we are at stage where encrypted AES key bin is ready. So now when I say do this in one shot, right? What do you need to send? You need to send AES key because that's totally secure, and you need to send AES encrypted bin, right? So that's the actual message, right? So you send those out. Now across the world, your Alice. This was encrypted with Alice's public key. So now Alice is going to use her private key. What does Alice need to do? First, she needs to grab encrypted AES key dot bin and decrypt it and update AES key decrypt, right? So that you get the plain text, and then we will need to change this file name in the AES decrypt, and if everything works, we'll get our result. Okay, so so we're Alice, so now we go into RSA decrypt. Decrypt. Okay. We received AES, encrypted AES key.bin via email. We plug in here our private Alice PEM. Same algorithm, of course. And now we're going to generate. In fact, I'm going to add a number here. Let's say 3, just so that's a file that never existed. So let's go ahead and do that. Okay, great. So that no errors. If we look at this, there it is. AES decrypted. Notice it has the same size, 16, so that's a good sign. Now we need to go into, that's the key exchange, correct? So we've exchanged the key securely, but now we want to decrypt the message. We also, when we received the encrypted key, we also received AES encrypted bin. This is our secret message. So we're going to go, we're going to go into AES decrypt. Okay, let's analyze it. Okay, AES encrypted.bin, this is the secret message. Remember, we already explained how this works. There's an IV associated with this. Now, this is the key, AES key, that we just decrypted via RSA, right? So we need to change this name to what? Decrypted 3, correct? That's the one that I just generated just now. And then after that, we need to know that we're using a AES mode CBC, which is something you've agreed on with Alice. Okay? And then this just prints out the message, hopefully, if everything is correct. Go ahead and do it. So it's AES decrypt. Did it work? It did work. Sure. There it is. Does this make sense, guys? That's essentially like a very key thing that you need to be able to do. Very important. Now, when you work with a partner, it becomes a little bit more complex because you have to keep track of which file you need to be using, which keys you need to be using, which files are safe to send via email, etc. So that's why this is one of the problems. I've given you all the code, but you still need to practice this with your partner. If you look, I think I have I guess, right space. I forgot to open it. Just give me a second. Let me stop sharing this recording. We should be recording. Share the screen. Okay. So we are ready to look at the next homework assignment. 350. Content. So you can start working on this one. PyCrypto. PyCryptoDome homework. So it says here, using PyCryptoDome, send a secret message to your partner. Use symmetric encryption to achieve confidentiality. The symmetric key must be exchanged securely via RSA. That's probably exactly what I just did. Any questions on that one? Do you guys understand that, everything is provided and I just demoed it effectively? But I did it by myself, so you guys need to work with a partner. All right, then problem. So we're ready with that one. With problem number 2, send a second message. This time provide confidentiality, integrity, and authentication all in one shot. That means one email. You can use email to exchange the files. You need to also complete a report and submit it, and you will need to demo both these problems. So that's what I was saying. I need to, yes, please. That's fine. That could be a second email. That's not a problem. But achieve all 3 principles in one email. That's the problem, essentially, the hard part. So to think that through. All right, so now I need to give you other scripts, right? How to calculate integrity, which is basically how to calculate a hash value, and authentication, which is going to be a digital signature. All right, so this will be, few new scripts to achieve these ideas. All right, so, but yeah, these are the problems. So we've completed problem number 1. All right, so we can go back to the virtual machine now. Here, okay. And I believe it says recording, so we are recording. Take a look at the video. All right, let's go back to the VM here. Control X. All right, so clear. Look at all the files that you have in here, right? There's a lot of files. But that's how it is. When on the scavenger hunt, I recommend that since it's going to be usually like 3 keys that you have to find independently and then combine them into a 4th thing, I recommend that you create 4 folders. I'll give them names like you're breaking into the CIA and you're breaking into the FBI, something like that. So create one CIA, FBI, a bank, and put all the respective files in each of those to minimize the number of files. All right. So let's take a look here. So we've done all the AES. I think we've done the RSAs, which is key exchange. Now we need to do signatures, which should be this one. Yeah, so let's try this approach. We're going to continue to use PK CS 1.15 version 15. This one will provide the functionality to sign, and it's not that long as far as the code, so should be okay. So let's try this. This is probably a good script. All right, so I'm going to create this file. This is a new file. I'm going to call it signature PKCS. You're going to use the same keys that you already created, right? The public and private key. But remember now, this is inverted, right? So you have to think about that. So because you're achieving authentication, so you use maybe your private key, and then everyone else can verify with the corresponding public key. So let's call this signature PKCS. So I'm going to do nano signature. So we discussed digital signatures a little bit on Tuesday. Remember, it's just the authentication part, signing something with a private key. So we need underscore PKCS dot view. All right. So we're going to do from crypto dot signature import PKCS. Oh, this is lowercase actually. PKCS 1 underscore version 15. Let's try this one, make sure that it runs for you guys. Does it run for you all? Yeah, okay. You know, since you all installed this year, there could have been an update or something. All right, so now we do the hash. So you guys are familiar with hashes. I'm just introducing the use of them in this library. And remember that when we sign a file, we actually sign the hash of that file, which is, it works really well. So from crypto dot hash import SHA 256, right? So this is the one we're going to use. We also import RSA. So I'm going to do from crypto dot public key, where the K is uppercase, public key import RSA. Okay. Okay, so now we need to bring in the key. We are so in this script, I'm going to do both the signing and the verifying together, but keep in mind, if you're working with your partner, it might make more sense to have one script for signing, another one for verifying. It's up to you. I'm going to leave that to you guys. I'm just going to demo this in one script, and I'm going to let you code that yourself. So I'm going to do F open. Here I need a key that I'm going to read. So this is going to be private.pem. Okay, private.pem. This is Bob. Bob is sending, so Bob's private key. So I read it. So my key F dot read, just like that. Okay. Then I'm going to import it into RSA so that the key is like in a data structure. So I'm going to say key equal RSA dot import underscore key. And what do I read? I read my, just like that. Do you guys see that? So we're just reading in the private key. And then that's going to be f dot close. Okay, and that gives us essentially the private key. Let's try this out. Make sure it doesn't error out. Okay, good. So that worked. All right, so the next step is right. So I'm just going to hard code a message here, and then you guys, so this, how am I going to do this? Well, we have to read the problem actually. Whatever I wrote on the problem, it might be that I'm asking that everything happens on the message itself, right? So we'll go to that. But let's just hard code a message here. Let's just say message. Remember, the key thing is usually you just have to put binary there. And let's just write a message here. Let's just say to be signed. With this, always check that it's like a multiple of 16 or something like that. But, try it out. All right, so this is our message to be signed, just something to test. So what do we do? The first thing is, now remember, I'm doing an actual digital signature, right? So the digital signature has two steps. It builds on the primitive of integrity. So first we hash, right? And then we apply RSA to the hash. So I'm going to create a hash here. I'm going to use my SHA-256 for this one, dot, and then I just create new with message itself. You guys see that? So I'm taking my message to be signed and using SHA-256 to produce a hash. And remember, we've done this before. These hashes can be printed with digest and everything is hexadecimal, etc. So here I just want to visualize it. So I'm going to do print hash. And we already know the definition of a hash. This is an object, actually. So we would need to, it may be something like dot digest. Let me take a look at this one. Hex digest, I think it is. Let's try hex digest. Hex digest. Yeah. So this looks a little bit more hexadecimal, right? But that's your hash value. If you ever need to send a hash value, you can send it this way. Okay, that actually you can put in an email, should be. Okay. All right, so now let's go back. That just creates the hash. We've created the hash. Now we create the digital signature, which is really just one line of code. But let me add a comment here. That's why I'm using this PKCS one. It's very efficient. So you create something called a signature. Okay. And we invoke PKCS1 underscore 15. We say dot new. And what do we provide here? We need to provide key. Which key? This key, which should correspond to your private key. Got it? All right, so that we provide that key. So now essentially the algorithm has the private key, and then we proceed to sign the actual hash value. Got it? So this is what we're going to do. And signature is actually a file that you would send. So you need to send this signature in a file. Do you guys understand that? So you can write binary or use pickle dump, either one. But just, you send that file because if you're Bob, you send this and then Alice needs to verify this using this file. Okay. But I'm going to leave that to you guys as well. So now what we need to do is do the verification. We're going to do verify. So this would be now Alice. But I don't think we ran this. So let's run it to make sure it doesn't give us an error. Okay, no errors, so that's good. And I have my signature. So now verification. Remember that in verification, it's really about true or false. I mean, that's really what we want to do, right? So we want to make sure that it was signed by that person. So it gives us true or false. So the way we do this is one approach. We now need F open. We need another key, right? So in this case, we need what? The public key. Okay, so here I'm going to use public dot pem, public dot pem, and we're going to read in the file R. So I've got my pem file, so I'm going to read it. I'm going to call it public key. And I'm going to use RSA dot import key. And in here, I'm just going to f dot read. That's just a little bit shorter code. Okay, so f dot read, close f. Close f. Okay, so now we have the key, and now we just need to verify this. So you also need to send the message, right? So the way that this works is you also need to send the message so that you can compare. So remember that here I hashed this message. So whether this is encrypted or unencrypted, you need to provide this in some secure way. So on the verification side, you would create a hash of that. So you would say SHA 256.new message. Okay, so that's the message. Oops, that's the message. Okay, and now the last step is to verify, where you're going to provide this H and the signature, and that's it. Okay, so we're going to create a try catch or try accept. So 1, 2, 3, 4. We're going to print false if it doesn't check out. And if it checks out, we're going to print true. True. And here's the last piece, PK CS1 15 dot new. We need to provide the key here. So in this case, the public key. Public key. And we're going to say dot verify H, comma, signature. So this should be the basic approach. Okay, so let's try this. Which makes sense because I'm good. Got it, guys? Do you understand the idea? So that's the essential process. Now there's several ways of doing this with all these libraries in PyCryptoDome. You may find better code, right? Better approaches. There's PyCryptoDome is a very large library. This is just like the simplest implementation of it. but essentially and closest to like the theory, if you know the process, right? So have a message, you hash it. I'll review here. Have a private key, have a message, you hash it. That hash then needs to be signed, right, by the correct key. Then that signature is really important, and you send it out. And then on the other end, you receive that message again. You need to double check it, get the hash, and then you verify. Okay. And that's the code. We're also going to do this with OpenSSL at some point so that you have both parts of this. Are there any questions? All right, so I think that's all the scripts actually. So yeah, so take whatever time we have left to start working on this problem. Let's go over and think it through, right? So before you leave at least, so let's see. I will end the recording here.